Hello, today we are going to go over your exam review study guide for trimester 2. All right, so we're going to get started. The first set of problems you'll see are inequalities, and remember that the only thing different about solving an inequality compared to an equation is that if you multiply by a negative number or divide by a negative number, you have to change the inequality. All right, so let's take a look at the first one. Remember, we're solving for W, so we're going to move the 12 over by subtracting 12 from both sides. And that gives me negative 25 is greater than W. Now, W is all by itself. This is perfectly acceptable. The only thing I would worry is that on a multiple choice test, make sure you understand that you probably want to write the W on the left, and 25 still needs to be, the alligator, if you will, still needs to eat the 25. So now we have W is less than negative 25. All right. For number 2, right away, I'm seeing m divided by negative 5, so a little alarm bell is going off in my head. And I want to make sure that when I multiply both sides by negative 5, I flip my inequality to greater than, so that should be m is greater than 15. All right. We're okay with number 3. We're going to divide both sides by 5, and we're going to get t is less than or equal to 20. Number 4, we have variable on both sides. I like to, so I don't have to worry about flipping that inequality. I like to make sure, if I can, if that first move I make keeps my variable term positive. So I'm going to get 3z minus 4 is greater than 8. Add 4 to both sides. 3z is greater than 12. And then when I divide by 3, I'm going to get z is greater than 4. Number 5 is probably the trickiest one here. I have to distribute that negative in front of the parentheses. And I'm going to rewrite everything out. So 7 minus 9r, and then minus r minus 12 is less than or equal to 25. After we distribute, we combine like terms. And that is the negative 9 minus the r is negative 10r. And then 7 minus 12 is negative 5. And that's less than or equal to 25. I'm going to add 5 to both sides, and that's going to give me negative 10r is less than or equal to 30. And I'm going to divide by negative 10. Remember, I got to flip. I divided by a negative, so r is greater than or equal to negative 3. And that's our answer there. All right. 6 and 7, not only do we want to solve it, we also want to graph it. And we got to talk about open and closed circles with this. But let's solve for t right away. And when I subtract 1, I get 2 is greater than or equal to t, or the way I prefer it, t is less than or equal to 2. And this will give us a nice hint as to which way we need to graph that. So I draw my number line. Here's my 0. And t is less than 2. 2 is right here on the number line, right? And less than or equal to, we're going to do a closed circle because 2 counts, and we're going to shade backwards. All right. Let's try number 7. We're going to add 7 to both sides, and that's x is greater than 10. Here's 0. Here's 10 on my number line. Open circle because it's not included. 10 is not an answer. It's strictly greater than. And remember, if your variable is on the left, you can think of this almost like an arrow, and that tells us what side to shade if you ever get confused. So I'm going to shade right of my circle. All right. Number 8 is simply a solve, so we got to distribute on both sides, and then we'll combine like terms after that. I might run out of room for this one. 12d minus 3 is greater than or equal to negative 12d. Ooh, I can already see this might be a no solution problem. We'll find out. Plus 12 minus 5. All right. And 12 minus 5 is what? 7. So we have, this won't be a no solution. 12d minus 3 is greater than or equal to negative 12d plus 7. So I'm going to add 12 to d to both sides. And that gives me 24d. I'm going to add 3 over here, and that's greater than or equal to 10. Divide by 24. D is greater than or equal to, divide by 2, 5/12. So there is that. All right. Number 9, which of the following is a graph of this? So or usually means we're going to graph to the outside, so I'm not thinking it's A or B. I'm going to solve this, though. So I'm going to subtract t from both sides. And that gives me 3t. I'm going to subtract 8 from both sides. So that gives me 12 over here. And when I divide by 3, I get t is less than or equal to 4. So less than or equal to positive 4. Less than or equal to positive 4. Part of me makes me think I might have done this wrong. Let's see. Oh, because this is negative 12, which makes me negative 4. So t is less than negative 4. So that's C or D. So A and B are, in fact, out. And I just have to solve the other side. I'm going to add 4t to both sides and get 7t is greater than 14. Divide by 7, that's greater than 2. Open circle, greater than 2. Yeah, so it's C. So on a multiple choice situation, I wanted to check to make sure, but one thought was one of them is greater than or equal to, the other one's less than. So it couldn't have been C or B or D because this was strictly less than or greater than, and same here. So we didn't have the closed circle to represent this. And then the other piece is the or usually graphs outside of our dots, which kind of knocked A out as well. All right. Number 10. So floor function. Let's see. M is less than 1. So this greatest integer problem here essentially means that no matter what, I am going to round this up to 1. Okay? And so I'm starting to think this is supposed to be absolute value. Yeah, so we're going to treat this like absolute value. And essentially that means any number I plug into this, we are going to, 1, make positive. Okay? And so anything I plug into that is going to be positive, and that number is going to be between -1 and 1. So that gives me that. Essentially, we're doing this. So m is less than or equal to 1. That's that way. And m is greater than or equal to -1, which should be the double filled in blank. Sorry, A, not C. The answer is A. There we go. All right, number 11. So we want to go through here, and to actually solve this problem, we want to actually try to solve these, okay? So let's start with F and hope F is our right answer. So remember, with these absolute value problems, we write one equation just like we see it without the absolute value, and we write the other one with a flipped sign. Oh, not that. With a flipped inequality and the flipped sign. So it became greater than 1 became less than -1, and then we solve it. So we add 3 to both sides, we get x is greater than 4, and I add 3 to both sides, and I get x is less than -2. So I need two open dots, good. Greater than 4 should be this way. Oh, we got it right away, and less than -2, so that is F. All right, bonus. Let's try another one. All right, what is the solution of this? So it's the same problem. We're going to graph it. So we're going to write one equation just like we see it, and the other one, we're going to flip the inequality and change the sign, and we have to solve those two inequalities. So we're going to subtract 4. -7x is greater than or equal to, let's see, -7 is 3 minus 4 is -1. We're going to divide by -7. And we're going to get x is less than or equal to 1/7. So that's the first one. And then on this one, we're going to subtract -4, and we're going to get -7 is less than or equal to -7. We're going to divide by -7, and we're going to get x is greater than, I had to flip it because I divided by a negative, 1. All right, so we have x is less than 1/7. So here's 0, and that's positive 1/7, so 1's here. Let's put 1/7 just here, and it's a closed circle. And x is greater than 1, so less than 1/7 graphs this way, and here's 1 graphs that way. All right, again, kind of a gray tor, so we're outside our 2 dots, and that should be a closed circle. All right. And we got more time. So Katrina's weight is within 8 pounds of her ideal weight of 120 pounds. What is her total weight range? So what we're going to do is we are going to say that. So we're going to look at her ideal weight, which we're going to write as that. And we want to say that she's within 8 pounds of that. Okay? So essentially what we're doing, to make a long story short, is we are going to say that we're essentially either adding 8 to 120 or subtracting, but here's the math behind it. So I write the first one as I see it, and I write the second one with a flipped inequality and that. So I'm going to add 120 to both sides. That's going to give me x is less than or equal to 128, so less than 128, and I add 120 to this, and I get x is greater than or equal to 112. So I know that the weight range falls between those, which is 8 bigger than 120 and 8 less than 120. All right, so for graphing the inequality, one thing I kind of like, what's nice about multiple choice graphs is if we understand how to graph, we can eliminate a lot of answers. All right, so the first thing I'm looking at is this graph has a y-intercept of -1, and every one of these tells me a y-intercept of -1. So I can't eliminate any that way. I know this graph is negative, so H and J both have a negative slope, but these two do not, so they are not F or G. And so then it comes down to how we're shading. And I look at the shaded area is below my y-intercept, which means less than, so the answer is H. Okay. If you were doing it by hand with graph paper, you'd plot your y-intercept. You'd use a -2 slope to get another point. You connect your dots, and then you'd put your pencil back on your y-intercept and ask what values are less than, and that shades below. And remember, less than or equal to gives you a solid line, and you can see in here that one of our lines needs to be simply greater than or less than, not or equal to. That's what the dash line represents. So now we have a system, all right, and these are all solved for y, so we can kind of do the same thing here. Yeah, let's take a look. And I'm seeing right away all of these have a y-intercept of, it looks like 1 or -1, which means they're probably counting by 2 here because they intercept there and there. So hopefully that makes sense. So we might actually have to graph these. I know that in this problem, the less than is negative. Okay, so less than with the dashed line is negative. So that's negative. Dashed line's negative. So we can't eliminate any that way. All right. All right, so up 1 over 1, 2, 3, 4, 5. That's 1/5. Okay. So the lines look good. I think we're going to actually have to figure out where they shade. So all of these say the same thing. So, and they all match the points we have here. So we got to figure out which one shades there. So less than 2x, -2x plus 1 shades below. So if I did 1, 2, 3, 4, okay, less than is sections 1 and 4, which is not my shaded region at 2. So I'm going to say that's out, which means that's out too. So we're looking at J or G. So greater than 2x plus 1 is zones 2 and 3, quadrants 2 and 3. All right. And less than 1/5 is 1/5 x minus 1 is 4 and 3. So that overlaps in 3, and to me this looks like the darker area, so it should be this one, but we'll check. So again, greater than is sections 2 and 3. Greater than on my solid line is 1 and 2. They overlap in 2, so it is J. Okay? All right, so for 16 and 17, these two questions here, we're going to try to figure out which what the solution is. So the 3x minus 3y equals -6 is this line, and the x plus 2 looks like the same line. Oh, it is. So that means there is an infinite many solutions. It's the same exact line, so it intersects everywhere, and that one's C. And then 17, I got to finish this one fast. Actually, I don't think I'm going to get to it. So I will continue this on the next video.